Question three says acceleration of an object is given by the formula a of t equals 1 over 2 bracket t minus 2 all squared. It tells us some information about the velocity, that at t equals 3, the velocity is 3 meters per second. And then the question is asking for the displacement or the net displacement from t equals 3 to t equals 7. So first thing is, make sure you understand the relationship between displacement, velocity, and acceleration. So that as we go from displacement to velocity, we differentiate, and we differentiate again to get to acceleration, and we would integrate going the other way around. This problem here starts with acceleration and asks us to answer some questions about displacement. So we're going backwards, or acceleration to displacement, or integrating. So I'm going to integrate the acceleration function to get the velocity function. So when I integrate this, I'm going to have v of t. I'm going to plug in the actual expression. The integral of, I'm going to put the negative 1/2 on the outside. And this becomes 1 over t minus 2 squared. Okay, so what that is a power rule problem. So we're going to end up with negative 1/2. This becomes the power from negative 2 to negative 1, so it becomes t to t minus 2 in the denominator. And then we have that extra negative 1 power, so we have to make sure we divide by that extra negative 1 power. I'm just going to put that negative 1 down here like that. Okay, and then we have our plus c. Okay, so simplifying that out, I end up with 1 over 2 bracket t minus 2 plus c, and I have to solve for that plus c. Now to solve for the plus c, I'm going to use that initial condition. T equals 3, the velocity equals 3 meters per second. So plugging that in, v of 3 is equal to 1 over 2 times 3 minus 2 is 1 plus c, and that's going to give me a velocity of 3 meters per second. Okay, solving for my c, the c value works out to be 3 minus 1/2, or 5 over 2. That gives me my final velocity function as v of t is equal to 1 over 2 bracket t minus 2, and then plus c is going to be plus 5 over 2. Okay, so now I've established my velocity function. The question is asking about displacement, so then I need to set up my displacement. So the change in d, I don't actually need to find the displacement function, I just need to find the change in the net displacement, or change in d. That's going to be the area under the integral from 3 to 7, or the area underneath the velocity function will give me the net displacement. So plugging in my velocity function is, and I'm going to take that, I'm going to write it like this, 1 over 2t minus 2 plus 5 over 2, and I'm going to integrate that. When I integrate that, I'm going to end up with 1/2 log t minus 2. Okay, so I've plugged in I've anti-differentiated. This is not a power rule because it's the 1 over t to the power 1, so that's a log function. I factored that 1/2 out on the outside because it's easier to deal with there. And then integrating 5 over 2, I get plus 5 over 2t. And we have our bounds are going to be from 3 to 7. At this point, I'm just going to plug in my bounds and evaluate the integral. So I'm going to have 1/2 log t minus 2 is going to be 5. So 1/2 log 5 plus 5 times 7 divided by 2 is going to be 35 over 2. That's going to give me the first part of that, minus 1/2 log 3 plus 5 times 3 divided by 2 is going to give me 15 over 2. Okay, so I'm just going to group together my terms. The log terms go together. I'm just going to factor out the 1/2. Log 5 minus log 3. I'm going to use some log properties and write that as, instead of two logs being subtracted, I'm going to divide the arguments together. So it's 5 over 3. And then 35 over 2 minus 15 over 2 gives me plus 20 over 2, or plus, I'm just going to write that as plus 10. So plus 10, and that represents my net displacement for that function given the acceleration that we started with, the acceleration function that we started with here.